Filtration. It is the process of shaping the X-ray beam. Why? Because we have to increase the ratio of photons which are useful. Means we have to increase the photons which are useful for imaging rather than the photons that will increase the dose or decrease the contrast. As you know from Bremstallen that the X-ray is polychromatic. Now, when this polychromatic X-ray will pass to the patient, the low energy photons will be absorbed by the patient's skin. When it will be absorbed, it will contribute to the dose of the radiation. Therefore, this low energy photon should be absorbed by, it is absorbed by filter, whereas the high energy photons will pass through the patient body. They will be useful to form the radiographic image. Now, there are two types of filter which absorb the low energy photon. These are inherent filter or added filter. Inherent means it is inherent in the X-ray tube and its housing, which are example glass envelope, insulating oil and the window. This window is made up of beryllium. Remember, window of the tube is made up of beryllium. Now, added filter means something is added in the process, which is the metal sheet which is placed in the path of the X-ray beam. This is either aluminium or copper, and it is given by aluminium equivalent. Now, what is aluminium equivalent? Aluminium equivalent is the thickness of the aluminium that would produce the same degree of attenuation as the thickness of the material in question. According to NCRP, that is the National Commission on Radiation Protection, if there is less than 50 kilowatt potential, then it is 0.5 mm of aluminum equivalent is used. Between 50 to 70, 1.5, and greater than 70, 2.5 millimeter at aluminum equivalent is used. Therefore, aluminum equivalent means the material in question. What is the thickness of the material in question which will produce the same degree of attenuation as the thickness of the aluminium that will produce the attenuation. Means 0.5 aluminium 0.5 millimeter thickness of the aluminium is used. It is producing the attenuation. So how much thickness of the lead will produce that same degree of attenuation as to that of 0.5 millimeter aluminium? That is the known as aluminium equivalent. Now let us draw the diagram. One side of the graph would be intensity, other side is the photon energy. We have drawn the polychromatic X-ray graph, and inside it we have drawn the red color graph. That means because of the filter, that portion between the red and the black, it is absorbed. This is low energy photon which was causing harm to the patient's skin. This is absorbed and removed by the filter. One type of filter is the wedge filter. What is it? It is used when one side of the patient is thicker than the other. There we use this wedge filter. Why? Because more radiation will be available to penetrate that thicker part. It is used especially in lower limb angiography. See the wedge shape of the filter. The patient in that thinner part, more radiation and thicker part, therefore it is used to penetrate the thicker part of the body where it is used. Now one more type of the filter is the K-edge filter, also known as a heavy metal filter. Let's draw the graph again, intensity and photon energy. Now if you will see, the attenuation coefficient of iodine is around 33.17 kilo electron volt, which is the K-edge of the electron, and the same of holmium is 33 to 55 kilo electron volt. Therefore, there is a window period between 33 to 55 because attenuation coefficient of holmium is there, means it will attenuate more. Therefore, X-rays will be absorbed maximally in that window period, and the attenuation coefficient of iodine is at that only 33.7. Therefore, if we use holmium filter along with iodine contrast, therefore X-ray photon energy will have that window period of 33 to 55, which is the range for iodine attenuation to absorb, and iodine is used as a contrast. It will absorb at that range and therefore give maximum beneficial of that contrast which we require. Let us take one more example of the KH filter. We specially use mammography. In mammography we use KH filter where we use molybdenum. Now molybdenum, the value of attenuation coefficient is 17.5 kilo electron volt of the alpha ray and 19.6 of the beta ray. Let's draw the graph where we have photon energy and intensity, 2 peak 17.5 and 19.6. Now when we use the K edge of the molybdenum, we use again molybdenum filter only, but the K edge value is 20 kilo electron volt. Therefore, after 20 kilo electron volt, the photon will be absorbed maximally, and we need only 17.5 to 19.6 because that is the main focus of the molybdenum. And if we use molybdenum KH filter, so after 20 kilo electron volt, all these things will be absorbed, which will be very useful because we don't need after 20 kilo electron volt. Therefore, it is very useful to use KH filter of molybdenum along with the molybdenum in mammography.